So, today we are going to talk about friction factor for laminar flow and how you can find a friction factor for laminar flow. You see, basically, the friction factor represents the loss of pressure of a fluid in a pipe due to the interactions in between the fluid and the pipe. And so, what is laminar flow? You see, the flow is said to be laminar if every particle that passes a particular point moves exactly the same path as followed by particles which pass their point earlier. Usually, the laminar flow occurs at low speed. So, let's first derive the equation of the friction factor for laminar flow. You see, for laminar flow in circular pipe, the average velocity can be written as minus r square, which is basically the radius over 8 mu, and we multiply it with differential of pressure over differential of x. We see basically the differential of the pressure over differential over x is equal to constant. So if we integrate uh, differential of x from x to x1 and differential of pressure from x to x1 plus net. So we get the pressure, which is basically a P2. So which is P2 minus P1, which is basically the change in pressure over length. You see, if I put the value differential over of P over differential of X in equation 1, so I get average velocity which says we have minus r square over 8 mu and we multiply it with change pressure over length. You see, our goal is to find the change in pressure. So you see P2 minus P1 is equal to minus 8 multiply velocity multiply mu multiply L over radius, square of the radius. So you can also write radius in terms of diameter. So uh, when when we write radius in the form of diameter, we get minus 8 multiply v multiply mu multiply L over d square and over 4. So you can write a change in pressure as delta Pn, which is equal to minus 8 multiply V multiply mu multiply L over D square over 4. And this is, you can say this is our equation 3. But you see, in practical flow, the change in pressure is given as which is friction factor multiply L, which is basically length multiply density multiply velocity scale of the velocity over 2 multiply d, which is diameter. I say this is our equation 4. And if we compare equation 3 and equation 4, then we get friction factor, which is equal to 64 over Reynolds number. And you see, Reynolds number is a dimensionless number, and it is used to find whether the flow is laminar or turbulent. You see, through this equation, we get that in laminar flow, the friction factor is a function of Reynolds number only, and it is independent of the roughness of the pipe surface. So, in order to get a better understanding, let us solve a problem. So, you see, in this problem, we are given density, which is equal to 894 kg over meter cube, and we have the value of mu, which is equal to 2.33 kg over meter square, and we have diameter, which is equal to 40 centimeter. And we have to convert it into SI unit. In SI, it is meter, so we get 0.4 meter. And we have velocity, which is equal to 0.5 meter per second. So let's find a Reynolds number. So Reynolds number is basically is equal to density multiply mu multiply diameter over mu. Uh, this is 0.5 is velocity. So I get a Reynolds number which is equal to 76.783. Now you see it is less than 2500. So it means our flow is laminar. So we have already found derived the friction factor for laminar flow, which is 64 over R. And when I put the value of Reynolds number in this equation, I get friction factor value, which is equal to 0.834.